All right, I guess we'll get started now with only these people. All right, Zachary, did you get the did you have her today? Anyone, do you know
Yes.
you had her today? All right, so you got the review. So we'll be going over the review today. I haven't even looked at it, to be honest. And we'll be going over the review. So, the first question is: a man is climbing up the ladder, is climbing up and down a ladder. He makes the following trips. He goes from the first floor to the third, from the third to the fourth, from the fourth to the second, from the second to the third. So what I would do is I would write down 1, 2, 3, 4, and that's as high as he goes. So it goes from the first one to the third one. So I'd go 1, 2. I'll keep it like that. I'll write 2 on the side. It's 2 steps he goes up. Then he goes from 3 to 4, so he goes up another one. That's 1. Then he goes from 4 to 2, so he goes from 4 to 3 to 2, which is 2 steps. Then he goes from 2 to 3, which is 1 step. And then I'll add 2, 1, 2, and 1. Add that together, and I'll get 3. I would get 6. Let's wait for Lois to get in here. I would get 6. That's how many steps he's taken. So I got 6 steps he's taken. And then on the side it says calculate his distance and his displacement if the space between each rung is 0.5 meters. So we go 6 steps total. Then I'll multiply that by 0.5, and I would get 6 times 0.5 should get 3. He travels a total of 3 meters. All right, so that's his distance. His total distance is 3 meters. Now we have to calculate his displacement. So with this one, you would see the positive. So he goes up 2 on the first one, so that's a positive. Then he goes up 1, so that's another positive. Then he goes down 2, so that's a minus. But then he goes up 1, so that's a plus. So then I would calculate plus, so 6, no, not 6, 3 minus 2 plus 1. I should get like 3 minus 2 plus 1. I get 2. Or a simpler way to do this, I just realized this right now. Look at where he started, and then look at where he ended. That's another way to calculate displacement. So he went from 1 to 3. That's 2 steps. That's another way to do it. And then since each rung is 0.5 meters, you do 2 times 0.5. And his displacement would be 1 meter. 1 meter upwards. Displacement has to have a direction. It's basically a vector. So that's what you would do. She messes up sometimes, like on the exit ticket for 1.4. If you put the direction, you got it wrong. This is going on YouTube, so gotta be careful what you say. Erase.
Was it like a Schoology assessment or something where it's like,
Yeah, it was like you got it wrong.
okay. Yeah, I'm sure if you just tell her, I think
Yeah,
she would
I
fix it.
told her.
Okay,
She
good.
doesn't grade them anyways. It's just a
Oh,
comprehension test.
I
Okay.
did it for fun. We didn't have to do 1.4.
Wait, Andrew, I have a question.
Yes.
It would be 2 steps above.
What?
Oh,
What?
is it a conversion for this, or is it just steps alone? What was the displacement?
Displacement was 1 meter.
Got it. Okay, I didn't get the conversion.
1 meter going up. You see a little arrow mark.
Instead of hitting erase the whole time, you can select, Andrew.
No. Alright, fine. Alright. Oh gosh, what did I do?
Sounds good.
Is it this tool? Yeah, okay. Alright,
Trained enough.
so that was number 1. Number 2, we're not doing number 2 because you have to go to that website. Y'all can play the game if y'all want to. So we'll skip on number 3 of the review. If you didn't have her today, you didn't get the review, So just look at my screen. And you can,
It's still on her Schoology. Like she posted it for our class.
oh,
Charlie.
okay. Then you can look at the Schoology and you'll have the review there. So we're moving on to number 3. And if you can hear the Spanish in the background, that's my mom. The graph represents a car's motion. In which sections is the car accelerating from rest? Which section? So basically,
Are you sharing anything, Andrew, right now?
do you guys not see it?
No, we don't see anything.
Oh, that's on me, dog. Let me go to share content, screen share. All right, how about now? I'll see this.
Yeah.
Fist of 5, y'all can see this.
Yes, we can.
I don't have fist of 5. All right, so in which sections is the car accelerating from rest? So rest is like standing still. So A, it's accelerating from a rest. The answer would be A, because it's accelerating from the rest. I would say D, but it's not. It's accelerating, but it's not accelerating from a rest. MG, is that correct? I say A is the point.
Would be.
Sorry, what are you asking about? A?
A.
In which section
B is a constant. Right.
Got it.
is the car accelerating?
Yeah.
So
A and D are both accelerating.
C is also accelerating.
It's slowing down. No, C's slowing down.
Here's the thing, though. Acceleration just means change in velocity. Deceleration does not. Okay, get rid of the word deceleration. I promise you. I promise you. Deceleration. That's the definition on there. But then in physics, do you see that physics definition?
Gain speed. Oh, physics. The
rate of change of velocity per unit of time. Get rid of the word deceleration from your mind. It just serves to complicate things. All right. Acceleration just means change in velocity. So when you're looking at a velocity time graph, the slope is telling you acceleration.
Look at B. It's asking in which sections is the car acceleration negative.
Then you would just say C. Whereas part A would be A, C, and D.
All right.
Right?
So, for a velocity time graph, as it's moving away from the point, it's accelerating. It's speeding up.
Okay, so here's.
I'm not talking about.
Can I give you some? Can I give you some quick notes, real quick? Just quick notes. All right.
Yeah. What's your notes?
Can you just go and write this down? I think it'll help. All right. When velocity and acceleration are in the same direction, you're going to speed up. And when velocity and acceleration are in opposite directions, you're slowing down. Because think of it like forces, right? Because they're both vectors, velocity and acceleration, when they're going in the same direction, it's kind of like they're pushing it, so it's speeding up. But then when velocity is fighting with acceleration, when they're in opposite directions, it's slowing down. Okay, so speed has to do with the directions of acceleration and velocity.
All right. Now, yeah. So MG says. So we basically answered 1 and 2. So 3A is A, C, and D, and B is just C because it's.
But actually,
accelerating.
Part A is, I think, just A, right?
Yeah, because it's from rest. Yeah, that's why I said it's from
there
rest.
You go. Okay.
All right. Listen, man. All right, and then C asks, how far does the car travel during section B? So section B, can I annotate on this real quick? Thank you. So to find distance in a VT graph, what you do is you got to make shapes. Wow, that's straight. So I'm making shapes to find the what do you call it? The distance. This is how you find distance with a VT graph. You gotta draw a shape. So I have a triangle right here. I got a rectangle right here. And then I can make like a triangle with a rectangle and so on and so forth. But we're looking for B. So B, we gotta find the area of B, the rectangle B. I can't speak. So it goes from 4 to 9. So that's 5. 1, 2, 3, 4. Yeah, that's 5. And it goes up 12. So the height's 12. So 5 times 12 is 60. So 60 is the distance it travels in section B. So 60 would be the answer. 60 meters. would be the answer. That's how you would do that. And then D asks, what is the acceleration of the car in each section? So now we got to find the acceleration. So now to find acceleration, you use this is what I use to find acceleration. So A equals change in distance. Give me 1 second. I had it written down. Yeah, change in velocity over time. I get confused over time. Another way you can write this is y2 minus y1 over x2 minus x1, which is basically, we learned this in like 7th, 8th grade with Mr. Finch, not that hard. So you take any 2 points. What I do is I take the endpoints. So, so to find the acceleration of it in A, I would take 0, 0 and 4, 12. So then I'll do 12 minus 0 over 4 minus 0. And that gives me 12 over 4, which equals 3. So right here for D, you would write 3. For DA, you would write 3 meters per second squared. In the test, for the test, if you don't do subscripts, so the way you would write it on the test would be 3 space m/s, then 2, because there's no subscript. She tells you on the test. But really, it's to the power of 2. So that's what A is. Now we have to find B. So B is
Another way to write it is, I don't know if like she'll have it set to only that, but another way to properly do the notation is ms to the -2 power.
No,
Is that what you were saying, Lois?
she does that?
No, she was saying
I don't think our teacher does that. And
okay.
so then we'll move on to section B. To find section B, that's pretty simple to do for section B. Really, it should be 0 meters per second squared because it's a constant and there's no acceleration. So if you see a straight line, B would be 0 m/s squared. You can do your work to check, but that really is the answer. And then we'll move on to C. DC. So I'd pick the 2 points. So I got 9 and 12. So 9 comma 12. And I got 11 and 5. So I do y2 minus 5 over x2.
5 or 6? 11, 5.
Oh, shoot. Yeah. Thanks, Mira. It's 6. Let me look. Let me look. Yeah, that's 6. Thank you, Mira. We got that. Delete. That. Delete. So it's 11, 6. 11, 6. 9, 6. Shit, I'm going crazy. Give me a second. 9, 12. Yeah, 11, 6. I'm going crazy. So 12 minus 6 is 6. And then 9 minus 11 is, doing this in my brain, -2. So then you do 6 divided by -2. And your answer is going to be -3 m/s2. The negative is telling you that it's slowing down. That's what the negative is showing.
No, not necessarily. Well, it is slowing down, but why is it slowing down? Because acceleration is negative and velocity is positive, right?
Yeah. Oh yeah, there's like a thing like if one's negative, then slowing down. If they're both negative, it's speeding up.
Yes. Now, if that segment had been in the negative, like if this is the y-axis, this is the x-axis. If that segment was down here,
it would be
speeding up.
Yes.
Both velocity and acceleration.
Yes. And then, so we did A, B, and C. So A equals 3 meters per second squared. B equals 0 meters per second squared. C equals -3 meters per second squared. Now time to do D. Delete. So D is exactly what we did. We picked 2 points. So 11, 6. Thank you, Mira. And that looks like 12. That looks like 15 and 10. So you plug and play, just like Mr. Finch says. 6 minus 10. 6 minus 10. Yes. 6 minus 10. 11 minus 15. So 6 minus 10 equals negative 4. And then 11 minus 15 equals negative 4 as well. So negative 4 over negative 4 is just a positive 1. So your answer would be 1 m/s squared. Because two negatives equal positive when you divide it. All that good stuff. So A, we'll go over this one more time. A is 3 meters per second squared. B is 0 m/s to the power of 2. C is negative 3 m/s to the power of 2. And D is 1 ms to the power of 2. Then we'll...
So just a quick check, what's the slope of a position time graph or displacement time graph?
What'd you say?
What's the slope of a displacement time graph? If you have displacement here and time here, what's the slope of that?
Mira, would you like to answer that? I would like one of the participants please like to answer that.
Displacement time graph?
Yes, the slope of a displacement time graph.
We've never gotten a displacement time graph, MG.
Velocity.
Is that distance? What do you call it? The distance time graph?
We call that velocity time graph.
Well, in the next section, do you see that you have a displacement time graph right there in the next section?
That's a distance.
Wait. Whoa, wait.
I think it's displacement there.
Oh.
Pretty sure that's supposed to be position.
Isn't it position?
Yeah, it should be position.
Position time graph and displacement time graph are the same thing.
Oh, really?
Yeah. Don't worry. Yeah, that's just technicalities there. Don't worry about that. But anyways, either way, what's the slope of a position time graph or displacement time graph?
Velocity.
Velocity, good. And Zachary, you know that from calculus, right?
Oh.
Yeah, see, now the calculus makes sense. It makes sense why we're doing what we're doing, right? So the slope of position is velocity, and what about the slope of a velocity time graph?
Velocity is
acceleration.
Distance. Oh yeah, you're right.
Now, the opposite of, it turns out in calculus, the opposite of taking slope is doing the area under the curve. And that's called integration. You don't need to know that, but if you take the area under the curve of an acceleration time graph, what do you get? Change in
Distance. Time.
Huh?
Displacement.
change in velocity, right? Because
Yeah.
to get from velocity to acceleration, you take the slope of the graph, but to get from acceleration to velocity, you take the area under the curve. And then to get from velocity time to position, change in position or displacement, you take the area under the curve of velocity time. Just like Andrew did in that previous problem, right?
Yeah. All right, so let's move on to 4. The graph represents the motion of a cart. In which sections or section is the cart accelerating? So we got a position or displacement time graph right here. So acceleration equals that. Oh my gosh. Oh. Now, let me just look at this real quick.
I think this time they're points rather than sections, right?
Yeah, the points. So in which points is the cart accelerating? From B to C, it's...
Okay, so no, it's still segments, but now you just call them BC rather than just one section, right? Okay.
line BC, line CD, line DE, line EF, line FG. All right, let's get right into this. So it's asking which cart is accelerating. So acceleration is happening from B to C, right? Yes. Yes?
Yes.
Yes. So it's accelerating. The position is changing. It's going up. Well, it's, yeah. To me, just All right. BC. CD.
Here's some other notes you
All
want.
right. Oh, yes.
If your graph is concave up, do you guys know what that means? Concave up,
No.
something like that,
Exactly.
right? That's concave up, and then concave down is pointing downwards. Okay. In a position, no. The bottom one is concave up, and then the top one is concave down, which you just drew in.
Okay.
Yeah. So just for your information, if you have position time graph, if you have concave down, that means your acceleration. That means your acceleration is negative, and if you're concave up, that means acceleration is positive.
So BC is positive,
Positive acceleration,
and then DE is negative,
negative acceleration.
but it's still accelerating, no?
It is still accelerating, but it's negative acceleration. Good.
So B to C, and would you count C to D as a?
CD is not accelerating. Can someone think about why CD is not accelerating?
Because it's going the same. It's going the same pace as the line. Okay, I get.
Because the velocity is the same, right? Because
all right,
change in velocity is 0. Yeah.
So for E, you would write B and C, line BC and line DE are accelerating because lines A to B, line AB is staying constant, line C to D is staying constant, and line F to G is also staying constant. There's not a change in acceleration in those lines. So your
Change in
answer
velocity.
change in velocity, sorry. Your answer would be B to BC and DE. All right. In which sections is the cart not moving? The cart is not moving in lines A to B or E to F because it's not changing the displacement or position, whichever one you like to call it. So E to F and A to B, they're not. The cart is not moving. Now it's asking in which section is the cart moving backwards? The cart is moving backwards in F to G because it's going towards the x-axis. That's if it's going towards the x-axis as a positive, then it's moving backwards. H. In which section does the cart actual velocity at any time equal to its average velocity over this section?
Wait, which one?
H. So in order to find this, blah, blah, blah. So do we have to MG? We have to calculate the average velocity.
You don't need to actually calculate. This is more conceptual. So think about what it says. So think about where the instantaneous velocity is same as the average. When does instantaneous velocity at a point equal the same as the average over those points? Is BC one? What makes BC different from? Yeah, BC is different because
BC is exponential.
Yes, or it could be something else. It could be parabolic, but parabolic, but we don't know that. Either way, you can see that the average velocity is the average velocity between BC is not going to be the same at each point, right? What about AB? Is the average velocity is the constant there? I mean, is the velocity constant there, right? That's essentially what it's asking.
Okay.
AB would be one of them, and then what other points would the average velocity be the same as the actual velocity?
EF and FG.
Yes. EF, FG,
and then CD as well.
CD.
Now, there is one more thing I do want to point. I don't know, because you guys haven't learned calculus yet, there is one point here where the average velocity equals the instantaneous velocity. Because as you can see, this average velocity is the same as, is parallel to the instantaneous velocity. Same here, there's a point here where the average velocity over the 2 points is equal to the instantaneous velocity. Does that make sense? You don't need to. I don't think you would be expected to know that, but there is a point, just one point. All right, there's just one point where that happens when the curve is not a straight line.
All right. So MG helped us answer basically all these questions. Moving on. Yes.
Ask us like those weird concave and we never covered that.
Yes, we haven't. We haven't covered that. You are correct.
So how have you guys learned to answer questions like that?
We haven't.
We've actually never had a question like that.
Got it.
Yes, we
Okay.
haven't had a question. Damn, oh God, I'm not the only one.
So Zachary, since you know this, since acceleration is the second derivative of time, right? Or of
Yeah.
position, sorry. That's why.
All right.
Second derivative is time. Yeah.
But you did teach us how to do this. All right. So what is the velocity of these cards in the section? Basically, we'll be using the same thing, except select. We'll be looking for velocity. So velocity equals delta d over delta t, where d equals displacement and t equals time. We'll be using the same formula, y squared minus y1 over x squared minus x1. So she's asking for each points in the line. So AB, that already looks like 0. So AB, since it's straight, AB is a straight line. It doesn't change in distance, but it goes up in time. You would write 0. So you already know AB is going to be 0 m slash s. That is first. So the first one is 0 meters per second squared. No, 0 meters slash seconds. Been a long day. So B to C is the next one we have to find. No, we don't have to find B to C. Next one we have to find is C to D. So pick a point. So 25, 40. And pick another point, the end point really. 40, 50. And now we have to find the velocity. So 40 minus 50 equals something over 25 minus 50. If my participants would like to please do answer this question of 40 minus 50. Thank you. And 25 minus 50. Thank you.
Negative
Thank you
25.
guys. No, too late, Lois. Too late. So negative 10 over 25, negative 25. That gives you 0.4 if you put into your calculator. So number 2, which is C to D, would be 0.4 m slash s. And number 3, which is E to F. So E to F, it's just like A to D, B. It's going to be 0 m slash s. And 4, F to G. So we're going to pick our points. Delete. Pick our point 75 and 60. And our last point, which looks like it's 85 and 30. Then we put that in, so 60 minus 30 over 75 minus 85. If my participants would like to participate in what 60 minus 30 is.
Wait. I'm confused on how you
I think you
got
did the last one wrong.
0 for E to F.
E to F.
Oh, wait, never mind.
Jay, am I wrong about
Or
that?
not E to. Never mind.
Am I wrong about
For CD, what did you get for a CD?
CD?
Yeah.
0.4.
What was the fraction you got at the end for that?
I don't. That's not what I got.
Negative 10 over negative 25. What'd you get, Zach?
It should be negative 10 over negative 15, right? Because it's 25.
We'll go over
Where
that one
C
again
is
right now.
25.
40 minus 25 is 15.
It's 10 over, let's see.
Negative 10.
5, 10, 15. The answer is 10 over 15, which is 5 times 2 is 10.
What?
Yeah,
It
that's
should be
what I got.
2/3. It should be 2/3 or 0.66.
Yeah. You put 25 on the
I put
denominator.
25? Really?
Oh, because you did 50-50, but it's
I see.
50-40.
It is?
Or 40-50.
Y'all need to, I'm a student, okay? Y'all need to correct me on these
I'm
things.
sorry, I was literally like flagging.
Mira,
Oh, I was kind of slow.
25
Yeah.
and 40. And this point is 40, 50. This is y2, so 40 minus 50 over 25 minus 40. Someone gave me the wrong answer. I asked for someone to give me. I think I asked Lois to give me that answer.
I said the right answer because you asked for 25 minus 50. You got the points wrong.
Not over 25 minus 40. Negative 15.
There
Look
you
at
go.
that, Lois. Look at that. So negative 10 divided by negative 15. That gives you, thank you, Zach, so much.
Hey, man, anytime.
0.666.
Wait,
Little
would it be 0.66 barred, or would you round it up to 0.6?
You would round it up in a physics course. You would round it up to
I'll put 0.67.
Yeah.
Just because I don't want to get my teacher mad. Delete.
Wait, do we round it up to 3 sig figs or 2?
3 6 6. So the answer would be,
Why would you round it up to 3 seconds? Is it just because she told you to do that?
yeah, she told us.
Oh, okay,
so
okay, got
that's
it, got it.
0.6. Yeah. All right. Thank you. Now EF should be 0 m/s, and then FG as we were doing before we got rudely interrupted. 65, 60, and 75, 30. So 60 minus 30 over 65 minus 75. If one of my participants could please answer the question of what's 60 minus 30.
30.
Thank you, Zach, for being an outstanding student. And 65 minus 75.
Andrew, he's not a student, he's a scholar.
Negative
Scholar.
10.
I'm going to check your work, Lois, because last time we got the wrong answer. So 30 divided by negative 10 gives you negative 3. So your answer for 4 would be negative 3 m/s. That's how you solve for I. All right, now we all got that. So, really, she hasn't taught us a lot of this stuff. I'm not gonna throw shade. So now we're looking at J. How far does the cart move in these sections from B to C and E to F? What was the answer to BC for the velocity?
You see, you can't calculate average velocity. Or, I mean, you can calculate average, but you can't calculate.
I didn't calculate it.
We didn't calculate
It doesn't
it.
ask. It doesn't ask.
Yeah.
Yeah, it doesn't ask. I just realized that.
Because the velocity isn't constant, so it's not going to be. Yeah.
All right, so this is easy. So we see, let me annotate. So we see it's at 10. So this is 10. And we see it ends at 40 meters. It's safe to say that it went up 30 meters. And that's how far it moved. Yeah? I'm looking at MG for his approval.
Sorry, I wasn't listening.
So I'm saying
Uh-huh.
it starts at 10 meters and it goes up to 40 meters. It's
Yes.
safe to say it goes up a total of 30 meters.
Good, good.
All right. So that's how you'd solve that question. Same thing with E to F. It starts at 60 meters and it ends at 60 meters. So it's safe to say it moves 0 meters. That's how you do those questions. And then we have a couple more minutes. We'll go over the last question.
MJ, I can't believe you one-upped me with the screenshot you sent in the group chat.
No, it wasn't. It's just because it shows the AP and
Not today.
Wow, thanks, Andrew.
What was on to do that? All right, so now we got 6. Using the velocity time graph below, determine the displacement along the following intervals. So we know we know how to calculate displacement with these type of graphs. So from t equals 0 to 2 seconds. So it's just like what we did up. Can I? Just like we did up here with the with finding the distance of b. We gotta use geometry in here. So what I would do is I would annotate and I would label this. It goes down -2, so we know -2 is the height, and it goes over 2, so we know it's 2. So what's 2 times -2? Anyone would like to answer?
-4.
Thank you, Zach. She's an outstanding student. -4. You can only do this in a VT graph, by the way. You can't use this in like any other graph. And so,
If you do this on an AT graph, what do you get then?
we don't know what an AT graph is.
An AT graph is acceleration time. If you do this in an acceleration time graph, what would the area be? Can you take a guess, maybe? Anyone?
The perimeter.
No. It would be velocity.
Okay, moving on from that side note.
Wait, Andrew, can you explain what you did again? I kind of lost you.
All right, so she told us this. This is like the one thing I paid attention in class was, Jesus, this is hard to do. Was in order to find distance and displacement with a VT graph, you would create shapes, triangles and rectangles. So let's look at this VT graph. You see this one on the screen? What we'd do is we'd create shapes. So we would just create lines to create shapes to find the change. So to find distance for this whole graph, you would do 4. What just happened? I think my guy is messing around with me. You would
yeah, go ahead, keep going. This is just a reference thing you can write down later. So keep going.
I don't know what I'm doing anymore.
Don't worry about what I'm doing. No.
Messed up my groove, man. Oh gosh. So oh gosh. Oh gosh.
Andrew, take a deep breath.
Oh gosh. I got a lot of stuff to do. Alright, so back to what I was saying. Take these, you would create shapes out of triangles and rectangles with thing. And to find the distance, so displacement is just like positive distance plus or minus negative distance and all that good stuff. But this distance overall is basically how much you've traveled altogether. So in order to find that with a VT graph, you would basically, I don't know how to describe this like in math terms, MG, but like she told us you would create triangles and rectangles to find the total distance. So we're going to find the total distance of this car's motion. So you would do 4 times 12 divided by 2, because that's how you find a triangle's area, and 4 times 12 divided by 2 equals 24. So I'd write 24 in here. And for B, I would do 5 times 12, which gives me 60. And then to find C, that travels from 5. That travels 6. And it also travels from 9 to 11, which is 2, so 12. So it travels 6. And then 2 times 6 is 12, so this is 12. And then 6 times 4 equals, I have to do this on a calculator just to make sure, equals 24. And then finally 4 times 4 times, I'm going crazy. 4 times 4 equals 16 divided by 2 equals 8. So to find distance, I would add 24 plus 6d plus 6 plus 12 plus 8 plus 24. And that's how you'd find the total distance in a VT graph. Did I explain that correctly? I feel like I missed some points, but if y'all have a question, I won't be shy to answer the question. Anyone got a question? You 100% know exactly what I'm talking about. All right. Let me. How do I? Oh, I can check chat. Oh, okay. I need to erase these annotations. So that's exactly what we're gonna do for that other one. The last question. Here. All right. Now it's asking for the displacement. So displacement is. You guys know what displacement is. I can't. Okay. Annotate. So you got -2 over here. 2. What's -2 times 2?
-4.
Thank you, Gaussic. I just thought of Gaussic. Real quick. All right, so we know that goes 1, and that height is, to me, that looks like 1.5. So what is, does that look like 1.5? Looks like 1.5, right? We're going to say 1.5.
Wait, what do you mean? Where's 1.5? Yeah, that's 1.5.
All right, so what's 1 times 1.5? Jesus.
1.5.
Thank you, Zach. Y'all were getting your calculators out for that one. I saw Mira going for a calculator.
I'm tired, okay. Please.
Thank you, Zach. And then what's 1 times 1?
1. Yeah, I didn't make calculator for that.
All right, then what's -1 times 1? Lois had to think about it. -1. All right, and then this ends at about 8. I'll say 8. All right, then what's 2 times 0.5?
1.
1. All right, so now we find all the distances. We find the distances. Now we can answer the question. So it's asking the displacement from 0 to 2 seconds. So the displacement is -4. So we put -4. And then what is it talking about? It's talking about meters. -4 meters. Is that? Would that be right, MG? -4 meters? Would that be the correct answer?
For part A,
Yeah.
part A would be -4 meters.
All right. So I'm doing this correctly. And then B is asking what is t equals 2 to 3. So 2 to 3 is 1.5. So the answer would be 1.5 meters. C, t to 3. 3 to 4 equals 1. So you put 1 meter. 4 to 5.
Andrew,
Yes.
you're solving for displacement.
Yeah, I know.
So you have a -4, so you have to add 1.5, right?
No, it's asking from 2 seconds to 3 seconds, 3 seconds to 4 seconds, 4 seconds to 5 seconds.
So the displacement distance should be
It's not asking for
Oh, just
total
during the time
displacement.
frame, not the total.
Just during this time frame.
I was solving for total. Oops.
In that
If we were
time
solving,
interval.
but yeah, Zach, if we were solving for total, we would do -4, and then plus this, plus this, plus this, plus this. You know what I mean? Now you had that correct, but we're
Yeah.
looking for the time frame. So
Wait,
for yes.
Would the distance and displacement be the same then if they ask for like the same time range? Like 0 to 2 seconds with the distance
Yeah.
be
Basically.
Oh, it would just be 4. Okay, got it. Okay.
Yeah, it would just be 4. It wouldn't have a negative. If it was asking for just distance, it wouldn't have a negative. Yeah. All right. And then 4 to 5, we see it doesn't change at all. So you would put 0 meters. That'd be the answer, MG. Look at him for
0, yeah.
Okay.
Where if it's just yeah. That would be.
And 5 to 6, we set that as -1 meters. And then we had 6 to 8, which we put as 1 meter. And that's how you would solve this question. And yeah, let me erase this. Everyone got that? Any questions about this? Lois, any questions about how to calculate 1 times 1? No? Check chat. Oh, that's just energy. Extra.
And I also sent an image onto the Slack that should help you. That really, this image really helped me understand it when I was first learning this stuff.
Now construct a position time graph. All right, so you can do that one on your own. So that's we just basically went over the whole review except for question 7, 5, and 2. Y'all can do that on your own. If you have questions, contact the Slack.
Concave thingy.
What, Mira?
Graph with like the concave lines in it.
Yes.
Do you think she's just gonna ask us to, like, if she gives us a graph like this, do you think like she would ask us on a test like what sections a car is accelerating? She wouldn't ask us for the velocity of that, right? Because you can't really calculate it.
I don't think
She might ask you for average velocity, right?
She might ask for like an average velocity, but I don't think she will, because we really haven't gone over that. She might ask like questions like this, like when is it accelerating? Like she might ask that question and questions like that, but I don't think she'll actually ask for the velocity, what velocity equals.
Just for review, how would you calculate the average velocity there from B to C?
I would do what I've been doing, y2 minus y1 over
Exactly.
2 minus
Exactly. Perfect. Good.
But I wouldn't take any point. I would take the first starting point and the ending point.
Yes.
Find the initial.
That's if it told you what's the average velocity over from t equals 10 to t equals 25. Now, if it had said what's the average velocity from t equals 10 to t equals 20, then what would you do?
Lois has her hand up. Lois, what was your question? Sorry, MG.
No, it's all good.
Sorry,
Important.
what did we get for F?
What do you mean F?
For 6.
6? Lois, what is
Because you put 1 meter earlier, but isn't it 0.5 times 2? Oh, okay, never
What's
mind.
0.5? What's 0.5 times 2? What's half of 2? Jesus, this is why we got that question. Another question wrong. All right. Also, this test is cumulative. It's gonna have unit 0. That's what I'm trying to say. So make sure you read up on unit 0 and know what you're doing, and don't forget to turn in your journal entry thingy, bobs. Your journal, your note checks.
Binder check.
Yeah, whatever. And that's all I really have for today. If you have any questions, please contact the Slack. This will be on YouTube, so I had to watch what I had to say. My comedic career couldn't start yet because of this. Anyway,
Andrew, you make teaching a very fun thing, which is a very good thing. It's very.
Oh, we have the unit review up here. Wow, I totally forgot about this. Yeah, see, I was right.
Concave ones in this. Oh, okay. Shoot, it's right there.
Oh, wow. Okay, so this is a
Okay, great.
unit review right here. So we are right on the last question. We were right on this question.
Wait, stay on 5. Already not moving. Oh, okay. We basically got the same thing. Yeah.
Yeah, we got the same things, which is good to know.
So I think we don't have to do that then, but I'm not sure.
So yeah, we all got the right answers during this review. So if anyone in the comment section is like, Andrew didn't solve this correctly, oh, I got Miss Kelly on my sides right now. So I don't know about what y'all are thinking. That's all I have for this review. If y'all need anything else, I'll just contact the Slack. And I'm gonna end the session.
Lois, I have a question for Lois. What's 5 plus 5, Lois? Just need to make sure. We just need to make sure.
Yeah, MG, she can do simple math. She just can't do multiplication.
Stop bullying me, guys. This is going on YouTube.